Okay, in this video we're just going to take a quick tour of the Axon shell, setting it up and just getting around inside of it. So when you first install the software, it's a zip file. You will unzip it to your local directory. And you can see there's a couple directories here. So the bin directory is where we have our scripts for launching the software. The lib directory is where we have our code. And we're specifically interested in the data directory. So this is where all of our Zeto data libraries are going to go. And they're going to be named whatever the qualified name of that library is right in this directory. Also, when you install, you may need to cd to the bin directory and do a change mod on your script. Your bash script here to run it. Make sure it's got the executable flag. Sometimes in newer versions of Macs that will not default. And once we're all set up, you should be able to run bin axon v, and you'll see the basic version information. So you do need Java installed to run this, and this is sort of the first step to make sure you've got things installed. Now, if you want color coding, there's one more other thing you need to do, and that is set this environment variable, data_print_theme, and you can look at it in the printer.fan docs for how this is structured, but it's basically just a color name for a couple different theme things in the shell. You don't need to do that, but if you want a little color coding in your shell, that's how you do that. Okay, if you're on Unix, we are installing a library called jline, which is how you get some nice command line interaction. I don't think you need that if you're on Windows. Okay, so now that we're set, let's take a look at the different ways that we can invoke Axon. So we basically can pass it a file name, and it'll execute that as an Axon script. You could pass it an expression right on the command line, or you can just enter the interactive shell. So the simplest thing is if you just enter no parameters, you enter in the interactive shell, you can type some expressions, evaluate them. When you're done, you can type in quit. Okay. We can also do that right from the command line. If we just want to pass some sort of function call or data transformation right on the command line, we can do that. And that will evaluate and immediately exit. Or you can actually evaluate a function and then enter the interactive shell by passing -i, which is the same way Python works. And lastly, we can create a standalone file with whatever Axon script we want to run. Let's just create a test Axon file here, which you can see I've got. And I can just run bin axon test.axon. And it will evaluate that script. Okay, so those are your different ways to interact with the shell. So let's go ahead and enter the interactive mode here. And if you hit the question mark, you can see sort of the key functions that you can that you'll probably use in your data transformation routines. If you want to look at every function, you can type help all. If you've used Axon before, then this is pretty much your core functions and the I/O functions, the math functions. You don't need to know most of these, but if you want to get details on them, you can type help with the name of the function. That will print the help here. Typically, most of these functions have an example section. So, for example, if you want to test out this example here, you can paste it in, and you can see it will evaluate that function. So now, every time we evaluate a function, we're going to save it to a local variable called it. Okay, and you can always get back and recall it if you want. So if I say 3 + 4, okay, and now I look at my it, you see it is now 7. Okay, of course we can assign things to variables too, and print them that way. Okay, so just a quick, looking at your functions, getting help, And then let's talk a little bit about your data set and your libraries. So whenever we're going to be doing our transformations here with the Zeto data types, then we're going to have a data set, which is haystack data, we're going to load in as sort of our virtual database. And then we're going to have a set of libraries that we're going to import to check that data with different types. So if you type to read all here, let's say read all site, you're going to see that the database is not loaded yet. Okay, so in Haxel or SkySpark, there's always a local database that you've got your data stored in. In the shell, you typically are going to load this from just a flat file on your file system with this load command here. So if we look at load, we can see it basically just takes some sort of JSON or Zinc or CSV file from your local file system and loads it in as the virtual database. Now I have downloaded the examples that you find on Project Haystack to my local file system. So for example, the Bravo database is here. Let me just use that as my load. I'm going to use the backticks here. That's a URI. And that's going to load that data set in as sort of my working data set as my virtual database. So if I do a read all site now, you can see that that Bravo site has been now pulled in here. And this site has, let's see, so about 1,000 points. If we look at some of the equipment types here, actually, so we can see we've got a bunch of VAVs, we've got a chiller plant, some boilers. I think we've got a couple of air handlers as rooftop units. Boilers, chillers, okay, etc. So you can sort of mess around with that data set and see what's in there. Now these are all returning grids, which we're dumping in the console. They all have a lot more columns than we can see here, so they're going to get clipped. You can also do a read by ID, so if I want to see a specific point here, let's do this, read by ID. And I can see like all the tags of that particular dictionary, which representing that particular rooftop unit there. Okay, so that's basically our data set. Let's look at our libraries. So when you write the using function, you can see that it's going to start off by importing the Project Haystack and the system libraries automatically, but you can also import additional libraries. For example, if we want to import Project Haystack.points, we can do that, or we can actually do star, and it'll import every library we have installed. So when you install this, at least in this version, you're going to have the Guideline 36, the Project Haystack Core, the Project Haystack Points, and sys, unless you want to create your own additional libraries. Now, once you have those libraries installed, all of those type names are available in my namespace. So for example, if I just type string, capital S, we're going to see that definition. Or, for example, equip, which is in the Project Haystack here. Or I have the Guideline 36, so Guideline 36 reheat VAV is now in here. And you can see he's got these required tags, VAV, hot water heating, single duct, as well as what we call a constrained query about the points that he's required to have. And we'll look at how we can use these types for our data validation in another video. So once again, that's a quick way to get around the shell, loading your database, which is going to be your working data set, and then also doing the using function, which is going to bring Zeto libraries into your namespace that you can use with your validation functions. Once again, leave the shell, type quit, and that is all for this video.